Then the transaldolase reaction. The transaldolase reaction. All right, we've got our 7-carbon fragment. 1, 2, 3, 4, 5, 6, 7. Let me go ahead and put everything. You know what? I need to make more room here. So 1, 2, 3, 4, 5, 6, 7. This is going to be OH. This is going to be a carbonyl. This is going to be OH. And then we have 1, 2, 3. Yes. And then we have our O phosphate. Okay. This is going to, so this is our cetohep 7 phosphate. This is going to react now with the glyceraldehyde 3-phosphate, which is a 3-carbon C, C, C. OH and OP phosphate. So what it's going to form is the following. So 1, 2, 3, and then we're going to be 3 and 6. Yes, so what's going to move? Well, let me just draw it out first, and then I'll tell you what moves. So we've got 1, 2, 3, 4. That's that. OH, OH, OP. And then plus our fructose 6-phosphate, which is going to be 6-carbon. 1, 2, 3, 4, 5, and 6. So hope I have enough room here. OH, carbonyl, OH, 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 and O and P. So here is what ended up moving over. These three were moved over onto this, so to make this. So that's this right here. This is what the transaldolase reaction does. It takes a 3-carbon fragment, pushes it onto the glyceraldehyde 3-phosphate to create a 6-carbon fragment. I have started off with a 7-carbon sugar. Now I'm left with a 4-carbon sugar. This became that. This became that upon transfer of this to that. Okay. So now let me go ahead and write. So the transaldolase reaction. The transaldolase reaction condenses, right? When we're putting, that's what when we put molecules together, it's a condensation reaction. Condenses a 3-carbon fragment with the glyceraldehyde 3-phosphate to form our fructose 6-phosphate. So here we have fructose 6-phosphate. Here we have our erythrose 4-phosphate. Here we have glyceraldehyde 3-phosphate. And here we have our cetoheptulose 7-phosphate. There we go. Fructose 6-phosphate and a tetrose. A tetrose is a 4-carbon sugar. That's it. 7, 3, 10, 4, 6, 10. We wanted to produce a 6-carbon sugar so that it can become glucose 6-phosphate. Okay, so that's the transaldolase reaction. Now let's go ahead and look at the final transketolase reaction. I think I'll go ahead and do this one in black. Now, we have now we're going to condense we're going to react a xylulose 5-phosphate with the erythrose to actually form our next fructose. So let's go ahead and do 1, 2, 3, 4, 5. So we've got 1, 2, 3, 4, 5. And this is our ketose. Remember, we're transferring a 2-carbon fragment. So this is OH, and this is O, and this is phosphate. And we're going to react this with our 4-carbon. 1, 2, 3, 4. So this is an aldose. OH, OH, and our OP. Okay, what we're going to, you know what, let me write these out. So this is cellulose 5-phosphate, and this is our erythrose 4-phosphate. Let me go back to black, and what we're going to end up transferring, of course, is this onto this, because that's what transketolase does. It transfers a 2-carbon fragment from a ketose to an aldose. Transketolase, it transfers a 2-carbon fragment from a ketose to an aldose. Here's our ketose, here's our aldose. So what we're going to end up forming is we're going to be left with 3-carbon fragment, which is going to be our glyceraldehyde 3-phosphate. Okay, so we produce an aldose and we produce a ketose. OH, this is O, and this is our phosphate. This is glyceraldehyde 3-phosphate. Now let me go back, plus fructose 6-phosphate. 1, 2, 3, 4, 5, and 6. So what we have is OH, we have that, we have that, we have this, and we have this, and we have this. So here we go. We are down to fructose 6-phosphate again. Those 3 sequential reactions produces the fructose 6-phosphate. The 3 sequential reactions on the mirror image produces that again. So here we had another 2-carbon fragment. That ended up over here. Another 2-carbon fragment is transferred from a ketose to an aldose. If you know nothing else, recognize that. A transketolase reaction takes a 2-carbon fragment from a ketose to an aldose. It just moves it over. That's it. And the final word on the pentose phosphate pathway. The enzymes, all of these enzymes of the pentose phosphate pathway, they are cytosolic. There you go. This closes out our discussion of glycolysis, gluconeogenesis, and the pentose phosphate pathway. Thank you so much for joining us here at Educator.com. We'll see you next time for a discussion of the citric acid cycle. Bye-bye.